Welcome to the Real Python Podcast. This is episode 58. This week's show is a bit different. We're taking a well-deserved short break, but we still wanted to share an episode with you. This Rewind episode highlights clips from the many interviews over the past year or so. We also hear from many new listeners who have just discovered the show. Welcome aboard. We wanted to provide a sample of the guests, topics, and questions we feature on the show. For longtime listeners, this will be a brisk walk through past episodes and guests. We talked with so many great guests, it was hard to narrow it down to the sample provided here. We hope you enjoy this podcast rewind, and we look forward to sharing a fantastic slate of upcoming guests. This episode is brought to you by DigitalOcean's app platform. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. This first clip is from episode 3. The guest is Brett Slatkin, and we talk about his book, Effective Python, and how he and his team are using Python at Google. As you bring it up, I'm thinking about, okay, is Python a great tool for doing that sort of infrastructure work?
Yeah, so I mean, it was. I think there's like a decision tree that I have in my mind, I've written down somewhere, and it's kind of like, what language should I use for my project? You know, this is flame wars and bike sheds aside.
Right.
I think that there's some simple things you can think about in order to make that decision. So for me, and I'm curious, you know, if you have any thoughts on this, like your view, but to me, like one of the first decisions is it a platform thing? So like if you're writing an iOS app, going with Swift is probably the right idea.
Right.
Right. It's, you know, you could try to do it with Python, but, and you know, some people try to cross compile or transpile or other things like that. And it works sometimes, but same thing, Android.
The number of boundaries there are going to be less, right?
Yeah. Yeah. You kind of want to go with the flow with a lot of the platforms. So, you know, same thing with like, if you're making a game, maybe you want to use C# or C++, just because the platform SDKs you need to use, that's what they're in.
Okay.
Platform aside, then you get down to like these performance questions. And so to me, there's like really three kind of performance questions, which is like, there's latency, there's IO, and there's kind of memory usage. And if you really do care a lot about latency performance, like if you can't afford a GC pause, then a language like C++ or Rust or one of these other kind of non-garbage collected languages that's super close to the metal, that's kind of the way you want to go, because you can't afford even a real-time system that's managing an airplane or something like that. You just can't afford GC pauses. Go is a bad fit, Python's a bad fit. But for IO bound, if you're purely IO bound and you don't care a lot about CPU overhead or latency, then like Python's like an ideal language.
Oh, cool.
Yeah, so that's my view. And so like, these systems for managing data centers are like perfect for Python because it's super flexible and you can be very effective, but it's mostly an IO bound problem.
Next up is a clip from episode 7 with Łukasz Langa, and we talk about the origins of his code formatter, Black. I was wondering what you can tell me about the origins of it.
Well, back in 2018, it was a rather, unorthodox idea, like, not to even call it kind of dumb idea to just start a new formatter for Python, right? Like, Python has been around since 1990. So what makes you think like, anybody needs a new formatter in 2018? And in fact, that was very much what I thought about this at the time. However, at the time I was working for Facebook which employs a lot of people with a lot of opinions, but at the same time, like has this kind of mantra of like, hey, like we should focus on the most important thing at all times, right? Leave the kind of the nice to have things for later, right? And yet I've seen code reviews be very often derailed by discussing like the dumbest things, like, you're missing a space, after this comma, or, or you don't have a comma at all, or, kind of, you shouldn't have used this many blank lines here or whatever else, like, those silliest things ever. So we tried at some point to adopt Google's YAP, right? This project that is kind of a few years older than Black. Kind of it was already stable and used by a bunch of companies and projects. So we felt like, hey, we can do this. However, we've actually found out that we really cannot adopt it wholesale, and that would be the only thing that would satisfy me. Not to have one team at Facebook use it, but to have the entire company just kind of dive like straight in and just like say, hey, we are formatting Python right like this now. We were unable to do this because YAP is kind of both very configurable and has this brilliant idea that kind of backfires then to implement formatting as a dynamic programming problem. So what that means is they think of every formatting problem as a problem of fitting things that you have in your virtual line, meaning if you didn't have any column size limits, a line could be just arbitrarily long, right? Very often it wouldn't be, because you wouldn't write while true comma and then just write more code. You would always just break the line after the colon. But some of the expressions, like, I don't know, a very big dictionary, if you had, no limits, you would maybe just put it in a single line. But we have limits. Maybe in your project, there are 79 characters per line. Maybe there are 80 characters per line. Maybe there are 120. Whatever the number is, at some point, you're going to hit a line that is too long, and you're going to have to fold it. You're going to have to break it into multiple lines. So what YAF is doing in this scenario is it's looking at a list of things that you, as the user, counted against a good formatting. You put penalty numbers in configuration saying, I don't like it when this thing happens. I don't like it when that thing happens. You apply a number of penalty numbers in your configuration. And then the theory goes that the dynamic programming algorithm minifies the penalty score for a given formatting. So it literally chooses the least ugly formatting possible for the given line, right? Conforming to this particular configuration file. So this, for the most part, works very well. And actually kind of is interesting in the sense that it's not like super consistent always, but when it's not, very often it's because you configured it not to be, right? So it acknowledges some edge case, right? So that's cool. However, that makes it a very black box, right? You cannot really explain to a person who is unhappy with a given formatting why a given formatting appeared. What particular rule was used for it. You don't really know. The only thing that you know is it tried a bunch of penalties, and this combination turned out to be the minimum penalty number for this line. So what you can do in this scenario is you can go to your configuration file, and instead of 48, put 49 in some particular, place. And maybe it will fix that particular problem that somebody came to you with. But then a bunch of other lines that used to be nicely formatted are going to be formatted differently now. So you're going to have other people coming back to you saying hey, this didn't used to happen. Why is it happening now? So it was all kind of very hidden from the end user, what is happening. And in my particular experience, most of the time people weren't after the perfect formatting, because any automatic tool that attempts this will fail. Inevitably, those tools don't understand symmetry. They don't understand aesthetics. They don't understand that a different file was formatted like this, and this one is supposed to be formatted the same thing. It's impossible, right? Those are very ambitious goals for a tool like this. So instead, what people would rather want to see is just some measure of consistency. Even if it's not perfect, at least you know why, right? So you can just kind of, shrug your shoulders and say, who cares? Let's move on. And in fact, we've had a more ambitious kind of formatter project at Facebook for a while, and that failed. So at some point, I just thought in 2018, I would like to have as a birthday present for myself, just for my team and maybe a few other teams, just the simplest formatter I can ever write that just almost, it kind of looks like JSON, does does the same thing all over the place. Like, with regardless of what bracket pair that is, it does the same thing everywhere, and just run with it. Weirdly, that was the right time for this for me. That, the initial alpha I pulled off in like 6 weeks, I think. It's still in the repo history, so you can follow that. But I obviously missed my birthday because, as a programmer, you're not supposed to hit your deadlines. It's the rules. I don't make the rules. But what I did actually make is Pi Day of 2018. And that was a cute date. I managed to just release the first alpha then. And by end of that day, I had like 500 stars on my repo.
Wow.
And I didn't understand what just happened. Like, I didn't understand why. Like, I did have this kind of manifesto style sort of, README that actually explained why I wanted to have an opinionated formatter that makes everything look consistent and how this makes things better.
This next clip is from episode 8 with Tania Allard. And we're talking about using Docker for data science and how she's encouraging to use it for reproducibility of project results. So that kind of leads to one of the things that is like a note in your like headline for your talk is the idea of reproducibility.
That's correct. Yeah. I focus a lot on reproducibility. I come from a research background, and we have a big problem in terms of reproducibility in research. And I think, especially when dealing with machine learning, it is essential that we can actually confirm or verify that if someone is, for example, writing paper or publishing the newest research in machine learning, that we can actually verify that these folks did what they said they did. And in that sense, that's where reproducibility matters, because then others can build faster on those algorithms or on that research, or even on an app that they're deploying somewhere else.
Yeah.
And it also increases level of trustworthiness that people can have when you're using somebody else's work.
How accepted is it in data science and machine learning space to use Docker as a tool?
I think it's becoming more and more evident that we do need to have robust processes to have reproducible or deterministic environments. Because in so many cases, people believe that if you make your code public or open source, then that makes your research or your machine learning thing reproducible. And that's not the case, because you still have to be able to reproduce the environment and also the data set that was used for you to get the same results. Because you can have many variations between certain dependencies if you're using a version of Pandas versus another, or Matplotlib, or even different distributions of operating systems can change significantly your results.
This episode is brought to you by DigitalOcean's App Platform. DigitalOcean's App Platform is a new platform-as-a-service solution to build modern cloud-native apps. With App Platform, you can build, deploy, and scale apps and static websites quickly and easily. Simply point to your GitHub repository and let App Platform do all the heavy lifting related to infrastructure. Get started on DigitalOcean's App Platform for free at do.co/RealPython. That's do.co/RealPython. This next segment is from episode 11 with Anthony Shaw, where we're talking about getting advice about testing in Python. Your article, as you talk a little bit about this concept of dry, of don't repeat yourself.
Yeah. So the idea with the dry principle is that you literally don't repeat yourself. Python has lots of different ways to make your code a bit more functional. So you can split things up into functions, you can extract pieces of code. It also follows the single responsibility principle. So when you're testing, if you haven't followed these principles, it'll actually make your testing harder. And that's kind of like a side effect. And it also is a bit of what I call like a code smell, which means that later down the line, if you want to refactor your code to have a new feature or like extend something or improve performance or something like that, like all these principles become a lot more important further down the line. So don't repeat yourself idea is quite simple, which is that, don't have two classes or two parts of code which have more or less like the same block of code over. So don't copy and paste code between segments.
Sure, yeah.
I mean, you can take this to an extreme, like you can have pretty much like a function for everything, but like there is definitely a middle ground, which is, try and remove things. When you're writing tests, the don't repeat yourself thing definitely comes into play. You will probably find yourself actually repeating yourself in tests, like the arrange, act, assert thing. You'll probably copy and paste tests quite a lot. But if you're using PyTest in particular, there are some techniques you can use to basically like give it a range of inputs and run a test for each one of those. So rather than copying and pasting the test, you can actually say, run this test function with this array of inputs, and it turns each one into a parameter. So that's called parameterization. And actually, in this year's PyCon, Brian Ocken did a talk on parameterization with PyTest, which is really worth a watch if you're interested.
Yeah, I just saw that one went up. Yeah, he also wrote a pretty popular book on testing, his PyTest book.
Yeah, absolutely. I recommend the book. Yeah, I recommend the book. I've got it right next to me, actually. I was using it yesterday.
Cool. Yeah, and his podcast kind of focuses on testing and testing code, though just like our podcast will go on a variety of topics too. So
yeah, definitely. It's more for like test. I think there's a lot of test professionals. So people who are like full-time testers, and there's a lot of advanced testing topics on there as well. So yeah, it's good to listen to.
This next clip is from episode 16. I talk with Hannah Stepanek about her book, Thinking in Pandas. And we talk about some of the steps that you might want to take as you import data into your data frames. So one of the things I was thinking about, to kind of go back to the normalizing topic, is putting things into sort of NumPy type formats as opposed to just like, I don't know, I think the normal term for it is an object.
Yeah.
A pandas object or something, right?
Yeah, exactly. Yeah, so that's really where like you should be thinking about the types.
Okay.
Yeah, like the NumPy types. So you want to make sure that your types that you're using are C compatible. And a lot of times when you just rely on Pandas read CSV or whatever data loader you're using, it'll spit out the types in just like objects, which are just general like Python object containers. So they could be anything, which are not C compatible and they're not performant and they're very large. So that's part of the normalization step, is to kind of decide like what types you want them to be, and probably along with that, like normalize your data such that it fits into that type. So like if you have any null values, for example, that's a very common problem. And it's actually something that they tried to address with Pandas 1.0. It's one of the major changes there, is like allowing, and like they built their own essentially like nan type or null type in Pandas 1.0, and they introduced, for example, like strings and Boolean arrays that can have nan values or like that Pandas null type in them, which is a huge win for performance.
Yeah, I could think so. Yeah, like normally it'd be nice to be able to not have it be like a full object just because there are some nan numbers or nan values in there when it could be just a Boolean or a smaller integer or something.
Yeah.
Okay.
And there are a lot of like, there can be some surprises with leaving them as like an object. Like if you have a column that you expect to be a number, but it's actually an object, and suddenly you have like an empty string in there, for example, and you're adding numbers together, that can definitely result in some very interesting values.
Yeah, I can imagine. I remember somebody going through and let's say it's a health inspection thing like you were talking about before, and maybe one of the columns is zip code or something like that. And, when you look at that data, you could potentially, I could change this to an integer. But another way to look at it would be maybe to identify all the different ones that are used and sort of like classify them.
Yeah.
Yeah, which is another technique, right? To kind of simplify your data to make it a little more performant.
Yeah. So there's a lot of considerations to be had there. I mean, there's also, you can always like take your metadata out entirely, like, and just have like a unique identifier. Pandas works a lot like databases. So if you're familiar with databases, and kind of like the techniques they use there, you can absolutely apply those to your Pandas data frames as well.
This next segment is from episode 18 with Armin Ronacher, the creator of Flask. And I had asked him earlier in the program about what he would change if he was to start the Flask project from scratch. And he kind of came back a little later in the program to follow up on that.
You had a question earlier, which was like, what would I have done differently? I don't think I would have done anything technically too different. Probably some things, but that's sort of debatable. I for sure would have done one aspect differently, which is sort of the community around it. I underappreciated how big it gets, and also how much time and effort an open source project can take when it gets to a certain size. And size not measured by number of lines of code, but just the amount of people using it. And I never really wanted to spend time on this, to a big fault, which is that I also didn't spend time on even thinking that I would have to deal with this eventually. So this kind of problem doesn't go away unless your users go away. And so I didn't handle very well how sort of this transition from I hack around on this thing to other people hack around on this thing actually went. So I think that's sort of the biggest change that I would do, is understanding that you need to spend time on figuring out how stuff is supposed to work when you're not involved.
Help direct it in some ways, or at least have directives.
At least maybe communicate like why was it built in a way it was built, so that other people can understand why it does that, and then find out how to give it to other people so that they can do something with it. It's a relatively complex problem, but
I hate to use the generic term of like a mission statement, but kind of that sort of.
Yeah, something like this, and then sort of paired with I wouldn't necessarily call it like interviewing people, but like have conversation with people about like, hey, why does it interest you? Like, would you want to work on this? Like this sort of building a community of like-minded people. Like the Django framework did a really good job in doing that. And I just never felt like that's something that I feel very inspired in doing. But then not doing it also doesn't lead to a satisfying situation. And so it took Flask really a couple of attempts to build this sort of Palace community around it. And and now it's there. And I feel like sometimes maybe I should have done certain things differently to have like maybe ingrained some ideas more. But then maybe it's like it shouldn't have been my choice anyways to say how it should go.
Is this something you want to refocus now, or
No. I think it's fine how it's doing now. It's just I probably would feel less detached from it if I would have communicated some of my ideas more. It's like I feel like it's no longer my fight to make it more backwards compatible, for instance.
Oh yeah, right.
This is like the community sees this differently now than I do, and so that's fine.
That brings us to the next clip from episode 22, where I talked to another open source maintainer, Russell Keith-Magee, and his project Beware. And we kind of dive into a deeper topic about the funding of open source projects.
The only thing really is that kind of the eternal open source funding thing is that I've been around open source for a long time. I've been around the Django project for 13 years or something at this point, 14 years, trying to work out how to fund open source, how to get companies to open their wallets, how to find financially viable models for open source is something that I'm very passionate about.
Yeah.
And we just don't have answers for. And in particular, even Django has difficulty finding funding to maintain the Django fellows. And in the case of something like Toga does not have someone using it in production for a huge production app. So there's not an obvious, and no one will until it is mature.
Right.
So how do we get from here to there? Like, if we agree, if you happen to agree that having Python on mobile and having Python being able to develop front-end web stuff is valuable, great. We all agree it's important. It doesn't get done unless there is money to pay for someone's development time. Because I'm here to tell you, developing it on the weekends is exhausting work.
Yeah.
And it doesn't happen quickly if it's being done on weekends. So we've seen multiple versions of this in the Python community. Like Beware has seen it, we got a grant from the PSF. 6 months later, we have a fully functioning Android implementation. That would not have happened without a grant from the PSF. PyPI lived in this development hell for years, and they got a grant from the Mozilla grants wing. And 6 months later, there was a finished version of PyPI that is there and is robust. Money makes things happen. We need to work out how to get that money into our community, into the things. And okay, if it's not Toga, that's fine. But we need the injection of money into the tools that we are using, into our ecosystem, so that we are not always playing catch up for the things that are changing, the developments in the ecosystem that we're seeing, so that we are doing our research and development to make sure that Python maintains and continues to be a useful platform into the future. And at the simplest level, it's open your wallet and donate to the PSF, because they are in a position to judge that sort of stuff. Or if you've got particular projects like Beware where you do believe in their message, give them money even though you're not using them, because it does make a huge difference. Like the day that I can give up my day job and actually go and work on Beware full time, and ideally not just work on full time by myself, but with one or two other people, so that I'm not just echoing around in my own head. Like that's the point at which the project is going to start, not just be, hey, look, I put out a little minor bug fix on the weekend. It's, hey, this week we delivered a new feature.
Yeah.
Because I was able to get 40 hours on this project, not 2 hours on the weekend whilst making sure my kids were fed.
Another really common theme on the show is to talk about Python itself. And I really like to ask questions to kind of dive a little deeper into how Python works under the hood. And in episode 26, I had Michael Kennedy on, and I asked him some questions about the global interpreter lock. So if we could take a digression just for a second, because I feel like it gets mentioned a lot, and I always get a little confused sometimes by these topics of like, okay, well, how is the Python GIL, the global interpreter lock, how is it stopping things?
How is it the problem? Sure.
Yeah.
So when I first learned Python and tried to understand this async stuff, I thought the GIL was a parallel thing, a multi-threaded thing. And technically it is, but the point of the GIL is to make non-parallel Python code run better. Okay, so the way the Python memory is managed in Python is every object is a PyObject instance, a pointer to a PyObject thing, and part of every PyObject is a field that says how many variables refer to this, right? The reference count. And so as soon as things stop referring to that object, it's deleted, right? In memory sense. So you have two choices. If you have true parallelism in Python, every time a variable is assigned or unassigned from one of these PyObject pointers, which could be simple things like numbers even, then you were at risk of a race condition around that object, right?
Like things wanting to get to it or update it.
Right. If like in one thread, one is unassigning, right, as another is assigning, even like variable plus equals 1 is not thread safe, because it's like read value.
Okay.
And then change value. And if they both go read, two threads go read, and then increment, you're going to end up with a +1 instead of a +2 situation. And so that reference counting section without the GIL would have to be thread locked. And if it's thread locked, then you have to, all of a sudden, incrementing a number goes to take a thread lock, block out all the other threads, increment the number, unblock all the threads. Like it's much more expensive to do non-parallel regular Python. Like its core memory management system becomes expensive because of that thread locking. So that what they said is, well, let's just let only one line of Python run at a time. That way only one variable assignment or unassignment could be happening, and we don't need thread locks. So the GIL is really there to optimize the serial version of reference counting.
This week, I want to shine a spotlight on another Real Python video course. It covers a topic we've touched on several times on the show, creating visualizations of your data. It's titled Plot with Pandas, Python Data Visualization Basics. The course is based on an article by Rekha Horvath, and in the course, instructor Darren Jones takes you through what the different types of pandas plots are and when to use them, how to get an overview of your dataset with a histogram, how to discover correlation with a scatter plot, and how to analyze different categories and their ratios. Whether you're just getting to know your dataset, preparing to publish your findings, or making a presentation, creating visualizations is essential. And like most of the video courses on RealPython, the course is broken into easily consumable sections. You get code examples for the techniques shown, and now all of our courses have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. This next clip is from episode 30, which features Gerarna Hjella and Christopher Trudeau talking about the new features of Python 3.9, where we dive into the PEG parser. Christopher, you said you wanted to go back and talk a little bit more about how the PEG parser is working.
So if you think about, your program is just a text file like any other text file, right? And so the parser is a program that reads that text file and does something with it. So it has to read it line by line. And when you're reading something line by line down at the micro level, it's actually reading character by character. So think of a simple assignment statement, right? So I've got the variable answer equals 42. So a parser has to pull off the A, the N, the S, and answer, like it's going along and reading that. And at some point in time, it has to make a decision about what kind of an expression this is. How does it know, is this a comparison or is it an assignment? And with an LL1 parser, when you get to the equals sign in answer equals, it can't know if this is an expression or an assignment or a comparison, because Python uses equals for assignment and double equals for comparison. Until it looks at that next character, it has no way of knowing. So this is in parsing, this is called something called look ahead, and an LL1 parser has no look ahead in it. So they have to do some fancy stuff to sort of backtrack into, once it's read the line, to reassess it and decide what it is. And you might think that, it only has to look one character ahead. When you get complicated expressions, you may actually have to look a fair ways ahead. So the foundational difference between LL1 and a PEG parser is PEG parser actually has what's called infinite look ahead. So it is allowed to sort of characterize these things and look at things in groupings. So when you start seeing the difference between the equals and the double equals, it'll know and it'll be able to handle that kind of thing quite succinctly without making the grammar for the language overly complicated. So again, this isn't one of those things that you're, myself as a programmer, I do my best not to think about this in any way or form, right? I don't want to have to think about it. That's why you run the compiler. That's what it's for, right? As mentioned earlier, features like PEP 622, you couldn't do them with an LL1 without getting very, very hackish in the underlying code. So this will allow the compiler to be more elegant. Down the road will allow us to introduce new features into the language that otherwise we might not have gotten.
And next up is a clip from episode 39, where I talked to Reuven Lerner about generators and generator functions. I guess we could dive back a little bit further and talk about kind of just the general idea of generator functions and how they're different from like a regular function. And I know it's hard in the podcast form. I always thought about that where it's like, I don't want to make it a tutorial, but what is this idea of a generator and how is that kind of like a unique thing comparatively to what's happening with a function? And then we can maybe go a little further into where you're talking about this idea of like the coroutine idea.
Sure. And by the way, we're recording, but I'm still waving my hands as I usually do when I talk. So
right.
we'll send stills for people to watch on the show notes. Right. So look, a regular function, when you run it, it runs, as I was describing before, linearly. Like it starts at the top, ends at the bottom, typically, and it returns something. It returns a value. And so the idea of having a function return multiple values is just laughable. Like you can call it multiple times, you get multiple values, but each time you call it, you're getting one thing.
Right.
And a generator function is a bit different. A generator function basically returns multiple times, but we don't use the return statement there because we use return, well, it's gone and done. So instead we use the yield keyword. And yield basically says, here is a value, but I'm not giving up yet. I'm just going to go to sleep and I'll be around when you next need me. And so here's a value, I'm going to sleep. Oh, I'm up. Okay, here's another value. And this happens through the iterator protocol, the communications between us and a generator function, or the result of running a generator function, which is a generator, is that every time we say next to it, give me your next thing, give me your next thing, give me your next thing, it's going to wake up, go through the next yield, and return something. Wake up, go through the next yield, and return something. So you could do something as simple as, some sort of iteration. But you can also sort of spoon feed information from a file or from the network, or even like infinitely large data. But obviously, we can't fit infinitely large data into our computers unless you get a really serious upgrade. And so in that case, you want to get it little by little by little, perhaps ad infinitum. So generator function allows us to do that. The thing is, generator functions are great, but this whole idea of, let's keep it around and have what's known as a coroutine, that's been around for a while, but I haven't seen people say like what we can and should do with it other than some esoteric sorts of descriptions. I think it was David Beasley who gave like a few talks in the past about like cool things you can do with it. But those got kind of complex, even by my standards, although David Beasley is like really smart. So like when he does something, if it's complex, like, he's the right guy to be addressing it. I think he was also the guy who gave me the idea of like describing it as the function going to sleep, which I thought was a fantastic metaphor. And so people have talked about coroutines, meaning let's keep this subroutine, let's keep this function around and fired up and ready to give us an answer. And whenever we need something new, we're not going to exactly say next to it. We don't want just the next thing, but we're going to feed it data. We're going to, like, it's two-directional communication. So it's not just give me your next thing, give me your next thing, give me your next thing. It's give me your next thing based on this. Give me your next thing based on that. So it can be, okay, you have infinite, like, you can give me information from the stock market, which is obviously an infinite supply of data. Give me your next stock trade of ABCD company or EFGH company or whatever. And the coroutine then has already connected to the service for the stock market. It's already all fired up. All it needs to do is get your input, like do something, and then yield it back to you. Get next input. And it'll just be waiting there. It's like, a butler or something waiting there.
Right.
And so I often thought of coroutines as like a solution looking for a problem. Like, okay, we can do this. Like, now what? Now that we've got this great technology. Now, most of the people in the Python world were like, oh, this is a great solution for concurrency. And so async IO is based on a sort of slightly mutant version of this. But I was like, well, I wonder if there's some examples how we can at least think about coroutines and perhaps use them in our system outside of the async IO context. And I'm not sure if I made a compelling case for where they can be used in production, but I'd like to think at least, I convinced myself that's an interesting idea and that it helps to explain that whole ecosystem of generator functions and coroutines better, to at least evaluate whether and where we'd want to use them.
And for this last clip, I talked to Brett Cannon, core Python developer, on episode 47 about unraveling Python syntactic sugar. Partly why I wanted to have you come on the show is we had talked about on a previous episode, David and I, about your syntactic sugar unraveling series. Mm-hmm. And I wanted to kind of just get a little bit of background on it and just kind of discuss some of the concepts that you're covering in it. And I think the first thing I wanted to talk about is just the idea of, I'm a little confused at the usage of the term syntactic sugar, and that might be my own personal not having a lot of background in computer science. When I think of syntactic sugar and the way I've heard it used in other places in tutorials and articles and such is things like decorators or other kinds of kind of unique looking structures inside of the language that maybe simplify the way something's written to kind of make it quicker. Mm-hmm. But I feel like as I go further and deeper into the series, I'm like, maybe I don't completely understand what this term means. So I don't know if you could kind of start there.
Well, I'll actually say your definition's spot on.
Okay.
It's just you have to be willing to let go of what you define as simple.
Okay, sure.
So to me, syntactic sugar is anything that is syntactically added to a language like Python that you technically don't have to have. Right? It's a sprinkle of syntactic sugar. It's a nicety. We could totally get by without it. It doesn't provide any magical semantics that you can derive from the language in some other way, but it makes life simpler. As you said, decorators is a perfect example. Decorators are literally nothing but an @ sign that just implies a function call that gets passed in a function object, right? It's really simple. It's not it doesn't do a whole heck of a lot. You could easily just define your function and then take the decorator, ditch the at, and just go name a function equals decorator, and then pass it in the function, and you basically have replicated exactly what decorators do.
Right.
I mean, and that's literally what it does underneath the hood. It's just, I think a lot of people don't realize that Python syntactic sugar, from that perspective of just giving you syntax that really underneath the hood, you could do another way without any issue, goes really deep. All right. And that's actually a lot of where its flexibility comes from. Like, I don't think a lot of people realize that like plus is nothing special. It's literally a method call.
Yeah.
And as you said, you can read the blog post, but it's just, I think, kind of mind-boggling and eye-opening, and to realize that so much of Python really isn't inherent in its design to the perspective of, oh, I couldn't make that work in Python if I didn't have it. It's actually, Python just gives you a lot of niceties to make your life more productive in terms of a software developer. But in actuality, we could take it away and you could totally more or less end up with roughly the same result. You won't have the nice plus symbol to mean addition, but you could totally fake it with method calls. You really don't have to have us give you the plus symbol to make it work. And to me, that's what syntactic sugar is just, if I took the syntax away, could you get the equivalent semantics some other way? And if the answer is yes, then yeah, it's a nicety, but technically we could take it away from you and you could still get the same end result.
So in this case, a large number of these, the way that Python's created as a language is it's basically almost everything is an object. Everything inside of the language is an object. And so when you're thinking of something like an integer, as it's defined, it has methods. And so to call something like addition on that, it actually is calling to these, methods underneath it. And you use the term magic methods, and I hear a lot of people use that also. And I just want to I'm kind of breaking things down because I want to make sure I got this clear. Whereas I hear a lot of other people say, oh, they really should be always called dunder methods with a double underscore in the name of it. And, I don't really care. Like there's always a lot of people that get religious on one sides of these battles, one way or the other. But I'm kind of intrigued in what the preference is between those two, and, which way do you kind of lean in that way?
Well, and funny enough, the language reference calls them special methods. So
special. Okay.
So there's three ways. So the way I call it is, I historically have called them magic methods or maybe special methods. I probably mentally might start calling them special methods because I keep reading the word special when I read through the language reference for these blog posts.
It's good to know.
But I still say dunder, right? When I talk about them, like the dunder add method, I don't say the magic add method or the special add method. So when I refer to them, I use the term dunder for double underscore.
Yeah.
But yeah, I usually technically separate them just because, for instance, you might see some projects use like a dunder version attribute to specify what the version is. Which, by the way, you don't have to do anymore thanks to import lib.metadata, which lets you actually query a package for the version. Just a total aside.
Good to know, yeah.
So I view it as a difference between the naming of something and whether or not it has special meaning to the language and interpreter. So that's where I draw the distinction between a dunder method, as in that's just named dunder add, versus, it's a magic or special method because the plus operator in Python actually will do something special based on the existence of a dunder add method. So that's where I draw the distinction in the terminology.
And don't forget, you can get started on DigitalOcean's app platform for free at do.co/realpython. That's spelled do.co/realpython. I want to thank all those great guests that we featured this week for coming on the show. And I want to thank you for listening to the Real Python podcast. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. I've been your host, Christopher Bailey. I look forward to talking to you soon.